John Blichmann from Blichmann Engineering joins me this week to talk about building an indoor brewery. This is BeerSmith Podcast number 151. This is BeerSmith Podcast number 151, and it's late June 2017. This week, John Blichmann joins me to discuss designing and building the perfect indoor brewery. Thank you to this week's sponsors, Craft Beer and Brewing Magazine. They're running an amazing deal right now, 20% off your subscription when you use the offer code BeerSmith2017. Every issue of Craft Beer and Brewing Magazine is packed with articles for home brewers and beer lovers, and you can read my new column called Ask the Experts. Take advantage of their special deal when you use the offer code BeerSmith2017 at beerandbrewing.com. And also the new BrewVision thermometer from Blichmann Engineering. This interactive wireless digital thermometer connects right to your iPhone or iPad and lets you remotely monitor and record temperatures. You can download your recipes right from the BeerSmith cloud and set updates and alerts as you brew. Get the BrewVision Bluetooth thermometer today. Another great innovation from BlichmannEngineering.com. Again, that's BlichmannEngineering.com. And finally, BeerSmith Mobile. The mobile version of BeerSmith is a perfect complement to our desktop brewing software. It includes all the tools you need to create recipes on the go, share them with friends, and act as a pocket brew timer. Check out BeerSmith Mobile at beersmith.com/mobile or on the Google Play, iTunes, or Amazon app stores. And now let's jump into this week's episode. Today on the show, I welcome John Blichmann. He's the president of Blichmann Engineering. Blichmann is the creator of innovative home brewing equipment like the Therminator Chiller, the Brew Easy, and the new Riptide brewing pump. John has been on the show at least 4 times before. John, it is great to have you back on the show.
Great to be here, Brad, as always.
So today you wanted to talk about electric brewing systems. So let's start with some of the advantages of moving to an electric system instead of your gas-powered typical brewing system.
Right. My first and foremost reason was just being in Indiana, which is not the coldest place in the country, but gets pretty brisk in the winters and gets pretty hot and humid in the summers. And geez, just being able to brew indoors was what really got me interested in electric. In fact, I actually started brewing indoors on a natural gas system and switched over. And we can talk a bit about why I did that. So,
I would imagine using a gas system indoors is not the best option.
Not near when I installed that electric system, it was pretty night and day, a dur moment. That's definitely the way to go.
Yeah, I think you're risking quite a bit if you put gas inside without an awful lot of ventilation, right?
Right. That is probably the number one thing is 2 things. Just the ventilation requirements needed, and it just it was just hot. Even with reasonable ventilation, it was hot, and depending on if you're God forbid going to use propane indoors, which I would never recommend. I had a commercial gas stove. It was fairly quiet, but the neat thing about gas or electric is it is just whisper quiet. So it's just a pleasant thing. There's a lot less radiant heat from the stove, from all that related equipment. It's a pleasant environment in which to bring indoors, especially since one of the reasons I wanted to get away from outdoor brewing is to get out of the heat too. So,
yeah, it's interesting. For those that don't know, the brewing industry is actually very seasonal here, at least for home brewing. It's definitely a winter sport, it appears.
Yeah, for the most part, and even, trying to brew safely, even in a garage, I got kicked to the curb pretty quickly after boiling over on our stove inside our kitchen. And I was instructed that I will be now brewing outdoors. So even brewing in a garage in a somewhat protected environment, you still have to have the garage door open fairly decent to get the fumes out, just for the carbon monoxide and nitrous oxides from your burning eyes and all that. And so it was still fairly cool and not real pleasant in the garage in the winter. So.
Well, one of the first decisions you have to make is how big a brewing system you should start with. I know most of us are brewing, say, 5 or 10 gallons, which is 19 or 38 liters for the folks overseas. How do you go about sizing your electric system?
What probably the most, I wouldn't say challenging. The first thing to think about when you're going to brew indoors is what is the biggest batch size I foresee myself wanting to brew. And the reason I say that is most likely you're going to have to bring some high current power lines over to your brewing area so you've got power. And what you don't want to do is put something in for 20 amps when then the next time, maybe a year from now, you decide, I really want to upscale to bigger batches, or I want to put a different brewing system in where maybe I need 2 heating elements, and now your power supply is not adequate. It's not that much more to bring in the higher current that you think you may need in the future, and then you've got very little extra infrastructure to add if you do want to upgrade the wattage of your system.
So, how many watts does it take to drive a typical 5-gallon pot, 19-liter pot to a boil, and then maybe the same thing for a 10-gallon?
For a 5-gallon batch size, you can get there's 2 main types of service you're going to have in a residential power. You're going to have your standard 120 volt. And most homes, except some older homes, are wired with 20 amp service on that. And you don't want to run right up at 20 amps because of a couple things. One, if you turn a light bulb on that same circuit, you're going to pop the breaker. The other is over time, you can get some nuisance tripping. So you really don't want to run, anything more than probably 18 amps or so on that on a dedicated circuit to make sure you're not going to be popping the breaker. And the 20 amps, that will get you at 120 volts, that'll get you a reasonable boil. If you're trying to run that. Yeah,
so how big a coil is that then? How many watts is that?
Oh, let me figure that out here.
Oh, it's okay.
That's a great one because it's very simple. You take the voltage times the amps you have available, and that's the main watt. So I'm going to go 120 times, let's say 18, and that's going to be 2,160 watts. So I think our elements are about 2,200 watts, if I'm remembering correctly, and that's our 120 volt version. And that I would say at 120 volts you're going to get a nice simmer. It gets the job done if that's all you've got available. Say you're in an apartment and you just don't have the 240 volt service available. But to really get a solid boil that's going to drive off the DMS and get you a reasonable boil off rate of, at least 5%, probably more like 10%, you really want to move to the 240 volt. And fortunately, most homes have a connection on your dryer or on your electric stove, your electric oven, that you can tap into and just run power over to for your heating elements. And in general, you can run one heating element at a time if you need to. So, for example, you can heat your strike water in your hot liquor tank and then pump over. And then, when you're ready to pump over to your mash tun, when you're ready to sparge, you can then run your just plug your heating element or cable over to your boil kettle heating element. So it's a little bit of moving around and that kind of thing, but even on a fly sparge system with heaters in multiple tanks, you can just move from tank to tank, which is a little cumbersome, but not too bad. It can be done. So.
But here in the U.S., the 240 volt plug is not your standard wall plug anymore. You're talking about a fairly, the really large plug that you typically use to plug in an electric dryer, right?
Right. It's completely different. Right.
Yeah.
Right. It's completely different. So you're actually bringing in power from two sides of your panel in the U.S. and that adds the 120 plus 120. That's how we get the 240 volts. So you'll actually have one extra wire in there as well. So basically, we actually sell adapters so that you can go from the myriad of dryer and oven plugs to what we use. It's very common industrial plug is what they call a twist lock, and that's pretty common. You can buy those at Home Depot or Lowe's, whatever, even Ace Hardware. And I will say that if you're gonna almost every home is going to be wired with just 15 amp plugs, and that's the standard plug everybody sees. However, if you want to run 20 amps, and you can check to see if your circuit's if your house is wired for 20 amps just by looking at your breaker panel. And if you have 20 amp circuit breakers installed, you know that the wire in your home is, well, it sure as heck should be anyway, will be capable of the 20 amps. And if you've seen 120 volt plugs where the flat spades are horizontal in a different direction, or you have one that goes a different direction than the others, they're not parallel, that's your 20 amp 120 volt service. So, and in Europe and other countries, they're going to be like Europe would be 230 volt, 50 hertz. The frequency doesn't really matter. It's more of the voltage. So they'd be 230 volts. So they're not having to deal with the 120 volt issue anyway. So.
But I mean, this is a concern even if you buy an off the shelf system, right? You have to make sure that the wiring and the breaker is going to support that system for even a 5-gallon system. Yeah.
Yeah, absolutely. And that's why going back to the first statement is, what is the biggest system I'm going to run? What are the heating needs for that? And how much power am I going to have to bring over? And at that time, then you'll know what kind of plugs you want to use. And there's a myriad of different plugs that you can get. Like I said, dryer plugs, oven plugs, or the twist lock type plugs are all fine. And I would highly recommend talking to an electrician and having at least them give you guidance, if not do the work for you, to make sure that everything is safely done. You want to make sure grounds are done properly, neutrals are done properly, and then of course your power lines. And of all things, that's the most important is making sure you have a ground fault circuit interrupter, the GFI or GFCI breaker in your system, and that will, since the tanks are open, you have that possibility of, although remote, you do have a possibility of energizing the liquid in the tank. However, if you have the ground fault, you pretty much eliminate that risk.
Yeah, that was the next topic I was going to bring up. Most people do not have a ground fault circuit interrupter installed in their typical wall outlet anyways. They are common in kitchens here. So if you have a kitchen or a bathroom that's an outlet that's near water, at least for the last 20 years or so, I think they had to be built in, right?
Right. Yeah. If you're within 6 feet of a source of water, I believe is the code in most places, you've got to have a ground fault circuit interrupter on that circuit. And the little 15 amp ones that you see plugged in the walls, those are, less than $20 probably now. But if you're talking 240 volt, most of those are not ground fault circuit interrupted. And to install one of those, you would put a GFI breaker inside your main panel. And, and again, electrician can do that for you and make sure that it gets wired properly.
So if you're working with a smaller 5-gallon system, if you can, certainly plug it into a GFCI outlet, right? Otherwise, you got to look at maybe installing a GFCI breaker or something like that, right?
Right. And again, the 15 amp GFI outlets are pretty common.
Yeah.
I don't recall seeing the outlets that are for 20 amp. If you end up, with more than, running like on a 15 amp, I wouldn't run probably more than about 13 amps. Otherwise, you can get some nuisance tripping. But if you're running up to that 20 amp end, you're pretty much then going back to putting a GFI breaker in your panel.
Which you really you need an electrician to go in and install a new breaker typically, right?
I would highly recommend that unless you've got a lot of experience doing that and know your local codes very well. So it's well worth it to have an electrician come in, because that's the biggest safety risk with electric. The biggest safety risk with gas is fire and ventilation.
And then, of course, if you move up to a typical 10-gallon system, which might have a 5,000-watt coil, you're plugging it into a 240-volt circuit now, right?
Right.
And that almost certainly does not have a GFCI, because typically, at least here in the U.S., the only ones that would have a GFCI are the circuits that are powering like a jacuzzi or a hot tub or something like that, right?
Right. So you'll definitely have to put one in your panel, and it's not that big of a deal. They fit in the same, so if you've got a 240 volt breaker in there, you can just pop that one out, and the GFI breaker will fit right back in, and you just have to wire the neutral slightly differently than you do for the plain breaker. And again, electrician's your friend here.
Yeah, and the GFCI, I wanted to emphasize, is really kind of a required piece of equipment. It's not really optional, right?
No, that's not an option unless you're trying to cleanse your own gene pool. and they're not,
because I mean, ultimately you're mixing water and electricity here, really.
Yeah, the things that you're not supposed to do, mix electricity and water. But, again, everything properly designed, they are very safe. We don't mean to scare you. But again, it's like most things, do the proper things and listen to people's recommendations, particularly your local electrician, to make sure that it's done safely.
So the bottom line is, I mean, unless you're working with a really small system, it makes sense to get an electrician involved early on, right?
Right. If you can plug it into your circuit at home, and some of that might be just changing out a receptacle to the 20 amp receptacle. If you're, you would need 12 gauge wire in your home.
Yeah, if the wire supports it. Yeah.
Yeah, if the wire supports it and your breaker supports it, that's simple enough to just change a receptacle out. But if you're going to the 240, I would definitely engage the help of a professional. And those GFI breakers are not ridiculously expensive. I think a 20 amp GFI breaker or 30 amp GFI breakers like $50, and a standard one's maybe 20, 15 or 20. So it's not an exorbitant cost to put that in.
Yeah. Well, in addition to the electrical concerns, the other big consideration is actually ventilation. And a lot of people don't realize that you need sufficient ventilation to run an electric brewing system, right?
Yeah. Well, to run any brewing system indoors, you really need that ventilation. So I'm going to pop over to my ventilation article that I did here, so I can kind of talk a little bit about that.
You recently did an article, I think it was for BYO, right?
Yeah, I did an article for our friends at Brew Your Own, and we talked about moving indoors and what you need to do for ventilation, and talked about some really boiled it down to some rules of thumb, and I some is that I generated just from my own experience, but most just talking with a lot of industry experts, and there's a lot of good stuff on the internet too. So. That was, I think that article was just a few issues ago. So definitely look up on Brew Your Own, and you can read it. It's just a lot of detail in there. So if you're looking to do that, that's a great place to look. But I'll give you the highlights right now.
Sure. So how would you size it? I believe you size it based on the size of the brewing system, right?
Yeah, there's a number of factors, and if you just there's no one answer. Oh, it's this size system, you need this many cubic feet per minute.
Oh, I want to mention first tell us why it's important up front. Why what happens if you don't have some proper ventilation?
Well, the purpose of the ventilation system is to get rid of anything harmful like carbon monoxide, nitrous oxides, um, and that would be like from the gas systems. The other is to get rid of steam and odors because you don't want gobs and gobs of steam permeating through your house. Not only does it make it smell wonderful, although your wife and children might do what mine do and say, "Dad, that smells nasty. When are you going to be done brewing?" Which is why I made sure I had a good ventilation system in. And then the other is to a large degree, one of the main reasons you're brewing indoors is to make sure you've got some pretty good creature comforts and it's not really hot or not really cold in the brewery when you're brewing.
And humidity can be a huge problem, right?
Right. You get all that moisture in there. You can get condensation on your windows in the house. It's going to make your air conditioning system run more to get that down because you're really boiling, on a 10-gallon batch, you're probably boiling, gallon and a half of water off during that batch. And that is a lot of liquid for a air conditioning unit to just take out, and it just makes it real muggy in the environment when you're trying to work.
I actually ran the numbers one day, and if you're in a fairly small room like I actually brew here in my basement, it can increase the relative humidity by 50% in one literally one boil, 50% increase in humidity.
Yeah. And the big thing there is, your AC will take it out, and it's not going to cause it's not going to make your bills skyrocket or anything, but it sure as hell isn't very pleasant working, brewing in 100% humidity if you can avoid that.
It can damage the drywall too and stuff like that. So
right. There's a lot of not good things that happen there. It's like the reason you don't vent your dryer into the room, where you vent your dryer, clothes dryer to the outside of the house.
Yeah.
Very similar thing. So.
Okay. So let's talk about sizing it now.
All right. So there's really a number of factors. The first factor is your heat source power. So if you're picking, if you're going to brew with natural gas inside, which can be done and it can be done safely, you've got to get rid of not only the steam and vapors from the boil kettle. In general, you're not getting much vapors or fumes or that thing from your hot liquor tank or your mash tun. Your hot liquor tank in general, you're going to keep covered. Mash tun remains covered most of the time. So it's really your boil kettle that you're really is what's kicking out the majority of the moisture. But with gas, most gas stoves are in the ballpark of 30 to 35% thermally efficient, meaning 1/3 roughly of the heat energy from the gas goes into the kettle, and the other 2/3 just kind of moves around the side of the kettle and enters the room. Mm-hmm. And your game plan there is, I want to get that not to go into the room, but I want it to get into my ventilation system and move out. So for gas systems, you've got to, you've got to ventilate not only the heat energy in the form of steam out of the kettle, but you've also got to get the other 2/3 that's coming out just as hot air from the burner. And that will help you make sure that you've got a pretty comfortable room, and then it's also getting rid of the noxious and poisonous fumes. I will add, if you are going to use gas inside, definitely put a carbon monoxide detector in the room where you're brewing so that if there's a problem, because it's a pretty slowly sneak up on you, and you may not know you're getting carbon monoxide poisoning until it's too late. So that's the one risk with the gas. And propane, I've known people that do it, but storing propane's heavier than air. So if you do get a leak, it is an explosive danger. And yes, there's furnaces that run on propane, but there's also lots of safety things that go in with it that are not going to be on your typical propane burner. So at a very minimum, don't store the tanks in the basement. Get them out of the basement or a closed room and get them outside or into your garage or wherever you store them. But The nice thing about electric is 100% of the electrical energy goes into producing heat in the kettle, and very little escapes from the, it doesn't escape as in hot air, but some does escape. You do have a little bit of losses just from radiative heat off of the side of the hot kettle, but that's about all you really have for radiation heat to ventilate. So by and large, with electric, it's just that heat energy that's input is the exact amount that's going out. You don't have any, wasted electricity, so to speak. So that's another benefit. While in most places, electricity is more expensive than gas per unit of energy, equivalent unit of energy. You use just a lot less electricity than you would gas. So it's actually quite inexpensive. I mean, I think one of our guys did a little calculation on it, or had a little meter, and it's less than $1 a batch to brew electric. So it's pretty economical.
So how do we go about sizing a hood system for a typical, 5-gallon, 19-liter or double-sized batch?
All right. So we've talked a little bit about heat source power. And so that's going to come into play a little bit later on. The other one is, so we've got a hood, and the purpose of a hood is to collect these fumes so you can pipe it out of the brewing area. So part of that is air velocity. You can't just take, if you're in a big open basement, you just can't put a pipe, or open a window with a fan in it that's clean across the other side of the building. You've got to, because you're not going to do a very efficient job of getting those fumes out of there. You're going to basically fill your room until it's full, and then you'll start evacuating it. So you want a hood that comes over the top. And the other thing that you'll need is enough air velocity to actually suck the fumes up and get them into the hood. So you'll want to have your hood designed so that it's covering enough of the area that you've got enough air velocity through there, and move it. And I've got some rule of thumbs that I'll share with you in just a bit.
So we're looking at basically a typical kitchen hood, or I know there's special ones that are like steam hoods that are more boxy, right? There's different hood designs.
They make some pretty decent residential / like the pro consumer hoods that you'll see. And if you're doing a 5-gallon batch and you just want to evacuate over the boil kettle, which is perfectly fine, that's how I do it in my house. You can use some of those, but you need but realize that most of those don't evacuate quite enough air to capture all of that, depending on what size you're brewing. 5-gallon batch probably will be adequate if you've got enough CFM, and those fans will have the CFM listed. What I actually did, I had a hood just custom made by a sheet metal shop, and it was pretty reasonably priced at our in the research lab at Blichmann Engineering. Mm-hmm. I actually went to a used restaurant supply store and just bought a used industrial hood for just a few $100, and it's like you see in a kitchen, and that thing works great. It's got a large surface area, and that's what we use in our little test lab. And I will say that used restaurant supply stores are your friend. You can find amazing sinks and tables and all sorts of things at very reasonable prices. So that's definitely a recommendation. So one of the next things to be thinking about is, okay, now I've collected the fumes, or I have a plan to collect the fumes. How do I get it out of the house? You can't expect to pump all this stuff through a dryer vent. It really, there's rules of thumb on duct diameter. So, for example, 8-inch vent will move about 225 CFM, and a 10-inch vent will move about 400 CFM.
And a dryer vent, I think, is only a 4-inch pipe, right?
Yeah, it's 4-inch, and then you're probably moving I don't know, 30 CFM or something. Not much at all.
I know I think it's under 100, and that's at peak,
Right, right. So I'm going to see if I have a little.
So, John, what are the typical CFM requirements for, say, a 5-gallon, 19-liter batch and maybe a 10-gallon batch?
Sure. I've got one here in my little article I'm looking at right now. And there's a couple rules of thumb, and that'll get you awful darn close. And that is you need 1 cubic foot per minute per 100 BTUs per hour of your burner. So if you have a 50,000 BTU per hour burner, you'll want to have a system capable of moving 50,000 divided by 100 equals 500 CFM.
So that would be like a gas system, right?
Right. So that would 50,000 BTU would be both a 5-gallon and 10-gallon batch size, something in that neighborhood. We've got the other ones are 70,000 BTU per hour kind of range for those, but that's most of those they'll have that published. So it's a pretty simple calculation. Just divide it by 100. And that'll give you the CFM you need. Now, if you're going to run 2 burners at once, you'll need twice that. So
that's a really big ventilation system.
It is, because 1,000 cubic feet per minute would be to properly ventilate that. Now on electric, So now on electric, I switch units, which is it would have been really nice if we just switched over to the metric system, but anyway.
Well, it didn't happen. They tried when I was a kid, but it didn't happen.
Yeah, me too. I don't know what the hell the deal was, but anyway. What you need there is there's
typical, you're looking at 2,200 or 5,000 for a typical small medium batch, right?
Yeah, so 34 cubic feet per minute per kilowatt. So for a 5 kilowatt electric heater, which would be pretty typical for a 10-gallon batch size, it'd be 5 times 34 equals 170 CFM versus 400 CFM.
So significantly lower. 170 is something you might be able to pull off with a typical stove hood, for example, right?
Right. And the other neat thing is, since you're not creating fumes and much radiant heat, you really only need to ventilate the boil kettle. I have just a vent hood over my boil kettle at home, and my hot liquor tank and my mash tun, they generate a little bit of heat, but nothing, as far as radiant heat, but it's not that bad. In general, I just leave the vent fan on, and it keeps the room, nice and cool. So that's really one of the main advantage, or a big advantage of electric, is there's just a lot less heat to have to get rid of in the first place. So those are some rules of thumb. Once again, it's take your BTU for a gas or propane burner and divide it by 100, and that's your CFM. For electric, it's take your kilowatts and multiply by 34, and that'll give you your CFM. Those are pretty good.
So that's the wattage of the heating element, right?
Yeah. Right. Yeah.
Right. So that's your base requirement, and I think you said you had another constraint based on the hood size, right?
Right. So you want a good hood size, or a good height for your hood is about 6.5 feet, so you don't smack your head on it constantly, and really ideally about 32 inches above your kettles. It's also a good rule of thumb to have 6 inches of overhang all around, because again, that heat's going to move out, and you just want to be able to capture it all.
Yeah, some of the steam spills over, right?
Right.
Yeah.
So, and to get enough air velocity that, so it's like, okay, here's how much you need just to actually, in general, eject this much heat. Okay, here's how much you need to capture that heat so you can eject it, and that's the air velocity. So, if you, for example, have a 4 foot wide by 2 foot deep hood, there's a factor in here which is 50 cubic feet per square foot of hood. So if you have 50 CFM per square foot of hood, you're going to pull enough air through that to suck those fumes up. So if you've got a 4 foot by 2 foot, you just take 4 times 2, that's your square footage, times 50, and you'll need 400 CFM to keep the air velocity high enough that it doesn't spill out of the hood. So you can size it based on that. That's one to make sure you have enough air velocity. Another one is air exchanges. So you want to make sure that you're in your room, you're exchanging enough the air enough times that you're keeping the fumes out and any of the radiation heat from the kettles off, and just drawing enough air into that area that the fumes aren't working their way backwards. And a lot of this stuff really comes from commercial kitchen design, and that's why there's just been, there's a lot of good rules of thumb. And while it sounds kind of like there's a whole lot to think about here, it really boils down to some pretty straightforward, simple calculations. Mm-hmm. And you're definitely better off oversizing it than undersizing it. For final sizing, I'll give you some of the drivers. The main driver is the heat load factor and the velocity factor. In general, if you've got the heat load factor right and the velocity factor right, you're going to have enough for the air room exchange factor, even if you're in a large room.
So basically, even as long as you got enough air velocity to move the heat out and also the steam out, I think for the hood size that you have, you're basically good, right?
Absolutely. So, if you're oversizing your hood, you may have some problem with spillage, as they call it, coming out. So again, minimum of 6 inches front and sides. You want the hood about 32 inches above the kettles. Closer is better, but again, you got to have the practicality of being able to stir and not smacking your head on it, and, and those sort of things. So duct sizing is another one. Make sure that you're using a duct big enough to carry those the air, and it's more than just picking a large enough diameter. You've got to stay within about 100 equivalent length. So I'll back up just a little bit on that.
So now we're getting into duct design, right?
Yeah. So there's a couple of, but it's pretty straightforward. Okay, once you figured out, say I need 400 CFM to ventilate my brewery properly. I look on my chart and I see that I need 10-inch diameter duct. Well, that's 10 inches with that it'll move at 100 feet. And unless you've got some massive palace, 100 feet will get you to an outside window or door pretty handily. Now, you're likely going to have to make some twists and turns to get it out there. So each 45-degree elbow equals 5 feet. Each 90-degree elbow equals 10 feet. Mm-hmm. So if you have 2 90-degree elbows to get it out, you've used up 20 feet. You can only use 8 feet or 80 feet of straight length. So
still will probably reach the window, at least in my house. Yeah.
Right. And if you're in doubt, move up a size and you'll have plenty.
Right.
Okay. And then, and a bit about picking a fan. There's a number of different manufacturers you can find on Zorro, in McMaster Carr. The inline axial fans work really well. Make sure you get one that's rated to at least 140 degrees. Otherwise, you're going to have problems with early hour failures on that. Mm-hmm. And the other thing I'll mention is fans in ducts can make a decent amount of noise. They're not, trivially priced, but having a duct silencer is amazing. It will take something that is annoyingly loud and make it so quiet you can barely hear it. And it is awesome being able to brew when you don't hear the scream of burners, the whine of a ventilation fan. If you've ever worked in a commercial kitchen, they are loud and it just kind of wears on you after a while. So again, you can get those in McMaster Cars or a number of different places like that. And I think I paid like maybe $300 for a really nice fan and silencer. Of course, that was a while ago, but
Mhm.
they're still working great, and it's just a joy to brew inside. And that article has got a lot more detailed information about these rules of thumb and all that. So check out Brew Your Own's magazine for that
So
article.
lots of things to consider, and I'll try and include some links in the show notes as well, because I know a lot of
Great.
people have questions. It gets complicated. It's hard trying to describe it too verbally here.
Right.
We're throwing out a lot of numbers, and
Yeah.
by the way, do you have any of this in metric too? Because I know I'm going to get the question.
In the article, I did, because I'm always as kind as possible to
Okay.
to the other 90%
Because
of the world.
we're throwing around cubic feet per minute and all this other stuff, and everybody
Yes.
else, 6-inch ducts and all this stuff, and everybody. I know all the
Yeah.
listeners overseas are probably scratching their heads, going, "What's that?"
I know. We're the only ones that don't use the good system.
Yeah.
I think the Brits got the last laugh. They suck us.
Well, I
with
mean,
their
you're an engineer and I'm an engineer, so we understand them. But yeah, a lot of people get confused. So we'll try and include some of that in the show notes. I wanted to move on to some of the other considerations that come into play when you're designing your perfect indoor electric brewery, and one of those, of course, is to have water for brewing and chilling, right?
Right, absolutely. It is very helpful if you're moving indoors to locate yourself as close as you can to water supply and drains. Electricity is fairly easy to, if you're in the same room, it's far easier, I think, to run power lines than it is to run plumbing and drains.
Yeah, I mean, I use an extension cord. I don't have the power exactly where I want it, but it's pretty easy to buy an extension cord and use it, right?
Right. Mm-hmm. Or even
just it's sized properly, obviously, but
right. Yeah. So that's my recommendation, is find where your not easy to move things are, which is your plumbing mostly, and locate yourself close to that, because it is really nice to have a nice sink. Something as simple as a wash, a laundry sink is great. Again, if you look at used restaurant supply stores, you find a commercial sink that is awesome with the side wings, so you can, spray down sanitizer on parts and have things dry and have a big enough place to wash. Since at least
I'm working with some of these 20-gallon pots. They're pretty big.
Yeah, mm-hmm.
Pretty sizable. And then, of course, you got to worry about water for chilling as well, right?
Right, and that's another thing to bear in mind too. And then when you have the water in, you've got to have a place to get the water out. It's not like you can just run it into the yard or that kind of thing like you can outside. So I've heard of some people that if they're near the laundry room, they just use the hot water to fill up their washing machine, and then they can reuse the heat. That's kind of inventive. But I've plumbed mine, so I've got a garden hose connection that goes into my drain system, so it's all closed. So I have the water come out. I've got a cooling water spigot that I can connect up to with a garden hose, and then it goes back into the drain system. So I've got a place for that cooling water. And then, of course, there's brewing supply water. It depends where you live, whether you're going to be installing like an RO system. Indiana has a great fortune of having some amazing limestone that was used to build most of the monuments in Washington, but it also gave us crappy brewing water that is almost like liquid drywall. So we have in both our lab and at home, I've got a RO system so that I can cut our water or just start from water from scratch. So having a location for that and an outlet for that is handy to have in your brewery too.
Yep. Well, I wanted to ask if you have any additional advice for folks that are looking to set up an indoor electric brewery. How do they get started on all this planning?
A lot of it is really putting down on paper what your needs are. And the biggest one is figuring how big of a system am I going to put in, because you don't want to have to redo things. Put the main infrastructure in where you can. And I've also in another Brew Your Own article, it was designing your indoor brewery, and that was a couple years ago. But you probably search their their page for that and get a lot more detail. But basically look for that infrastructure like we talked about with the power. If you've got to run it through your power through 3 walls from the garage and all that, you're going to spend some money. If you can locate things closer to that and your plumbing, that's definitely the way to go. The other thing I recommend is definitely making scale sketches of your brew layout and cutting little pieces of your equipment to lay it out so that it's all going to fit. You've got enough walking room and where everything's going to be located, and just kind of walk yourself through your brew day. Do I have everything I need? Is it convenient? Am I having to run up and down stairs with big, heavy, carboys of water or who knows what? And just kind of think through those things, and then you'll just have a lot more pleasant brew day.
Yeah, I'm always amazed. I put a electric brewery in here in the fall, and it's just a lot of little things you don't think about, like all the little connectors and back flushing and cleaning, and all this stuff comes into play. Quick connectors and all these things that you end up using on brew day, but you may not have thought all the way through initially.
Right. Mm-hmm. And of course, one of the other big things to be thinking about that's difficult is getting a 10-inch ventilation pipe outside. So, think about how am I going to get, or an 8-inch, whichever you need, how am I going to get that to an outside wall cavity? Running it up in the joist and out the rim joist to get it outside, or how you're going to do that. So that's another consideration.
Mm-hmm. I wanted to give you a minute at the end to talk about, I know you've launched some new products that are pretty exciting, and there's the Blichmann website there on the screen. I was wondering if you want to talk about some of the new stuff you got going.
Yeah, absolutely. We've been busy. I think a lot of people have seen our BrewVision that's been out for a while. It's your digital brewing assistant. It's far more than just a thermometer. I absolutely love using that, and you can download direct from BeerSmith your recipes from BeerSmith Cloud.
Yeah, it's tied into the cloud, which is cool.
It is, and we all know that BeerSmith is the only software to have for brewing.
Well, it is the one that most people choose. So,
yep, I started on ProMash years ago, and I converted a number of years ago over to BeerSmith, and it's amazing. It's a great piece of software. So, what else? We came out. We listened to all the input from our customers and made some changes to our new beer gun. And we come out with our new beer gun, more ergonomic, ambidextrous, which is great, and because I'm a lefty, and just made the tip more retained, so no more lost tips, and completely tool-free disassembly, includes all sorts of good stuff. So
I like it's got the accessories built in, which is nice too. Comes with them.
Yeah, it comes with that, and comes in a nice storage case, which is great. Also came out with our Cornicle. That's a really neat, it's kind of a combination keg and fermenter. You can use it as just a straight up fermenter. It's got tons of features, pressure capable, so you can push your beer through filters and all sorts of neat things. Very competitively priced, and it's just also, you can eliminate the need to transfer it to a keg. Just flip it over, switch the bottom out to a keg bottom, and you're in your keg ready to go. You can even kreuzen your beer because it'll handle those pressures. You can carbonate it while it's fermenting.
Yeah, I know you've been doing some pressure fermentation too, I think, right?
Yes, I've been doing some work with Chris White and Gordon Strong on fermenting under pretty high pressure, up to 30 psi, to suppress ester formation. So being able to make lagers at room temperature and very quickly. So you can turn lagers in just a same time it takes ales to go. Or even one of our next things is going to be seeing if we can make a real nice, pleasant ales at elevated temperatures, like 75 to 80 degrees. So eliminating the need to have temperature control. So Chris is doing some analysis to quantify the changes in esters, and Gordon's going to lead up a tasting aspect of it, and we'll be publishing those results on our webpage. And
yeah,
also,
we have you guys back on in a couple
Yeah.
months to talk about the results of that. I know you're kind of in the middle of the pressure fermentation experiments right now.
Yes, tonight I get to keg 3 of the 4. So we ran one at ambient pressure, one at 15 psi, another at 30 psi, and then I've got a control that's the typical lager profile. So good stuff. Munich Helles, perfect for the summer.
And of course, I actually wanted to mention, because I've been using one of these, you got your new Riptide pump, which you
Yes.
just came out with, which I think is really cool.
Yeah, we really, again, I've been brewing since '91, and the March pump it's a workhorse, but it's got, it's really designed as a hydronic pump, and we just took some of the things that we that just kind of drive us all crazy about it to improve on it, and that was it, adding an ability to vent the air out of it so that it primes better. Making an enclosed motor so we're not trying to worry about spilling wort on it.
And it's super quiet too.
That was another thing, making it quiet, putting a base on it so that the thing just doesn't tip over, and you can hold it up, or a switch, having a switch so you can turn it on and off instead of having to run over and unplug the thing. And then having a cord that's plenty long. I think we put a 9 or 10 foot cord on the thing that you can wrap up on the base. So just a lot of things to just try to make it really perfect for homebrewing. And we even put our G2 style valve integral to it.
Yeah, I really like the valve because I had a really hard time. Typically you take a pump and you're going to put a ball valve on it, but I had a really hard time when I'm chilling the wort getting the temperature dialed in where I wanted. It was almost impossible to get that ball valve in the right place to get the temperature that I wanted on the output.
Right. Ball valves are really intended to be on-off valves. They're not really good control valves. So you'd use a gate or a globe type valve for flow control. And, and that's really what the G2 style valve is. And it's very linear, very easy to finesse the flow. You're not having
Right.
to
I mean, this thing, I can just dial it right in. I'm just sitting there looking at the thermometer.
Yeah.
I just turn it a little bit. Okay, there we go.
Yeah.
Really nice.
It's been a great pump. Everybody that's used it in our field testing just loved it. So
yeah, really nice.
Check it out. Those are
just
on
came
our,
out, I think.
Yep. And,
okay. Well,
yep.
John, thank you very much for coming on the show. Really appreciate you being here.
Absolutely. Thanks for having me, Brad. I'm looking forward to being on again.
And again, my guest today was John Blichmann. He's the president and founder of Blichmann Engineering. And of course, you can find them on their website at blichmannengineering.com. Thank you, John.
Thank you much.
Well, a big thank you to John Blichmann for joining me this week. Thanks also to Craft Beer and Brewing Magazine. Every issue is packed with great information for homebrewers and craft beer fans. Take advantage of their fantastic sale now and get 20% off when you use the offer code BeerSmith2017 at beerandbrewing.com. And also Blichmann Engineering, creators of the innovative new BrewVision wireless thermometer. Remotely monitor your brewing system from your iPhone or iPad, record data and alerts, and grab recipes directly from the BeerSmith cloud. The BrewVision thermometer, another great innovation from BlichmannEngineering.com. And finally, BeerSmith Mobile. The mobile version of BeerSmith is a perfect complement to our desktop brewing software. Check out BeerSmith Mobile at beersmith.com/mobile or on Google Play, iTunes, or the Amazon App Store. Thank you for listening, and I hope you have a great brewing week.